This is the lesson for Chapter 6, Section 3, titled Linear Functions, day number 2. So looking at the first part of this problem, it says that you are controlling an unmanned aerial vehicle, and it's a UAV for surveillance. The table shows the height, y, in thousands of feet. So here's the y in thousands of feet. So this is 65,000, 60,000, 55,000, and so on, of the UAV in X minutes. And so these are the minutes that it's at its certain height. So you can see how it's going down. At X minutes, it was at 65,000 feet. At 10 minutes, it's at 60,000 feet. So it's going down. So that's the word here. So you see after you start, it's descent. So descent means you're going down and from the cruising altitude of probably that 65,000. So write a linear function that relates y to x and interpret the slope and the y-intercept. So let's find out what the slope is. Remember, when we do the slope, we have y minus y1 over x minus x1. So I'll take two of the y values, these two right here, 65 minus 60 all over, and then I have, since I started with 65, I got to start with the 0, 0 minus 10. So I go ahead and do the subtraction. I got 5 over negative 10. So that makes a negative 1 to 2. So what that means is for every 2 minutes, we're going down 1,000 feet. So the minus sign means we're going down. And again, 1 represents 1,000 feet, and over 2 represents number of minutes, and so that's what's happening. Every 2 minutes, we're going down 1,000 feet. So now we still need to write the function. So the function again is going to be in this form: y equals mx plus b. And so we know what the slope is. We just need to know the y-intercept. And actually, we have it right here. But if we didn't see that, we could use the point slope formula: y minus y1 equals m times x minus x1. So we could substitute some numbers in there. Y minus 65 equals, and then I'm just going to use that negative 1/2 times by x minus 0. So you can see when you use 0, when you have 0 comma 65, that is the y-intercept. And you'll see that here when we go ahead and solve. Y minus 65 equals negative 1/2 x. And so when you add 65 to the other side, you end up getting your answer. So you can see how the function is y equals negative 1/2 x plus 65. So now they want us to interpret the slope and the y-intercept. Well, here's the slope. This is the interpretation of the slope. So the y-intercept is the initial height equals the initial height prior to descending, prior to going down. And so that is, which equals 65,000 feet, because we are in thousands of feet. And so now we're trying to graph the linear equation. Well, we just use what's here, height in thousands of feet. So I'm going to write down height, and this is in thousands of feet. And down below we have time. Time is in minutes. And so I'll go ahead and plot some points here. So I'm going to go up by 10s, actually let's go by 5. So I'm going to call this space is 10, 15, 20. So skip every other one, and I'll just go up by 10s that way. And for the y-axis, we're going to end up going up by the same value. Let's go up by 10s. So 10, and this will be 20, 30, 40, 50, 60, and 70. And then we'll plot the points. So we started at 65,000 feet. So that was the initial height of this unmanned aerial vehicle. And from there, we're descending. Now we're descending one space, going over 2 spaces. Since I'm using a 10 or a 5 to 5 graph, I can go ahead and just follow what the slope tells me. Down 1 over 2. And see, that's going to be down 1,000 feet, and for every 2 minutes. And so or in this case, it's down 5,000 feet for every 10 minutes, and that's what this would be, down 5 over 10. So I continue doing that, and you can see what this looks like. So I can continue this graph all the way down as far as I can go, and you can see what it ends up looking like. So it continues down until we end up hitting the ground. And so now it says find the height of the unmanned vehicle when you stop the descent after 1 hour. Okay, so 1 hour is, we need to change our hour to the same time unit we have here. So if we were in hours, that wouldn't help us out. We need to be in minutes. And so 1 hour equals 60 minutes. So let's go ahead and take that 60 minutes and substitute into our function. So negative 1/2 times by 60, and then plus the 65. So it makes negative 30 plus 65 leaves us with 35. So that would be 35,000 feet is the number we would end up being at. And so let's see if we have that right at this point right there. And that's at the 60 minutes, right there, 60 minutes, and 35,000 feet is where we maintained, or we stopped the descent. And so from there, if I really did that graph correctly, I would end up having to erase this part here, and we would end up having that graph go out in this direction. And so it would be a piecewise graph, then that the graph changes directions. We've got two different slopes that we're dealing with. And so that's what we end up seeing on that problem. Let's take a look at the next one. And here it says the earnings Y in dollars of a nighttime employee working X hours are represented by the formula, or the linear function y equals 7.5x plus 30. The table shows the earnings of the daytime employee. So the table has the daytime, where this function right here represents the nighttime. Alright, so let's go ahead and find out some information here. It says which has the higher hourly wage. Well, let's write down the hourly wage of the nighttime employee. His formula goes like this: 7.5x plus 30. Remember, the 30 represents the initial amount. So this is his initial value, initial amount. So he gets $30 no matter what. So not even for working 1 hour does he get that $30. It's probably like a nighttime employee like benefit. You know, it's hard to get employees to work at nighttime because people like to sleep. So that's the extra incentive to go there. But he doesn't earn as much. See, this is his wage. And so a wage is a rate, and his rate is the slope, and that is $7.5 per hour. That's what he's earning there. That's what that represents. And so let's find out what the daytime employee is. And so we can find out that by using the slope formula. So I'm going to subtract the y values. I'll do 25 minus 12.5. And that's over 2 minus 1. So 25 minus 12.5 over 2 minus 1. So I do that work and I get 12.5 over 1. So this daytime employee, the rate of change, or the wage, is $12.50 per hour. So we see that the daytime employee's wage is higher. So we'll write that down. Daytime employee's wage is greater. And we can show that with a math statement. 12.5 is greater than 7.5. And so now it says write a linear function that relates the daytime employee's earnings to the number of hours worked. And so we're going to go ahead and set up the equation. Y minus y1 equals m times x minus x1. I'm going to set it up using point slope. So I know a point, I can just pull off one of the points from here. We'll do this one. So y minus 12.5 equals the slope of 12.5 times by x minus 1. So we distribute, and I got y minus 12.5 equals 12.5x minus 12.5. So I go ahead and add the 12.5 to both sides, and you see how the 12.5s cancel out. They make 0. So this employee, the daytime employee, doesn't get that extra incentive to work because it's during the daytime. It's not as hard to get them to work then. So they earn more, but they start off with less. And so what we want to do is, in the same coordinate plane, graph the linear function that represents the two employees. So let's go ahead and call the x-axis hours worked, and we'll call the y-axis earnings. Let's fix that. And we'll go with the values here. Let's go by, to be able to fit it on our graph, let's go by ones going this way. So this is like a half hour. This is 1, 2, to kind of spread out the data a little bit. 4, 5, 6, and 7. And then going up, let's go by fives. And so that's 10, 20, 30, 40, 50, 60, 70. All right, so the first one, the nighttime employee, we started off with $30, and then he earns $7.50 per hour. So $7.50 is hard to fit on here, but if I double $7.50, that makes 15. So going up 15, so this would be 10, 15 over 2, and I made 2 right here, that would be a point. And then I could do that again, going up 15, so this is 5, 10, 15 over 2, so this is 1, 2, that would be another point. And I could do that one more time. So up 15 over 2, put me right there. So this is the line for the nighttime employee. So I'll write down nighttime. And the daytime starts at the origin. And so we'll start there, and it's going up 12 and a half. So 12 and a half is the same thing as 24. And so even 24 I have a hard time fitting on this graph. If I double that, so I have 2 hours, these earn $24, so it'll be about right there. And then after 4 hours, these earn $48. So, and well, let's see, 40, actually instead of, let's see, 20, after 2 hours, let's fix that. I was thinking 12 exactly. After 12.5, so it's 50 or $25 after 2 hours. So 25 is a point on that line. And after 4 hours, you would have earned $50. So 50 is going to be right there. And then after 6 hours, he's earned $75. And so that's where the two lines end up crossing. So we'll go ahead and draw that line. And there it is. And so this is the daytime employee. So what they're asking is interpret the graphs. And so what we could say is the nighttime employee earns more prior to, it looks like it's 6 hours. So at 6 hours, they both earn $75 right there. So prior to 6 hours. And then after 6 hours, the daytime employee earns more. And so that's what we end up seeing there. Let's take a look at the next problem here. It says manager A earns $15 per hour and receives a $50 bonus. So that's going to look like this. Remember, our general formula goes y equals mx plus b. So y would represent the earnings. That's what this would be. X would represent hours. I know that's hours because of right here. Hours right here, dollars per hour. So that's your M. So $15 per hour times the number of hours plus a $50 bonus. And so that's manager A. So manager A. And then it says the graph shows manager B. And then asks which has the higher value. Well, this one starts at 0, 0. And so let's figure out manager B's wage. And so manager B. And so we go ahead and find the slope of the line. So I'm going to do 75 minus 0 over 3 minus 0. So that makes 25 when I go ahead and do the reducing. 25 over 1. So that's $25 per 1 hour manager B earns. So manager B earns more per hour, $25 per hour compared to, and then it was $15 per hour. Oops, wrote that right over the 1 there, $15 per hour. And so let's take a look at the next one. It says, after how many hours does manager B earn more money? Well, let's go ahead and find out when they earn the same, and then we can find out when, after how many hours they earn more. So let's take the manager B, the $25 per hour, and set it equal to manager A's wage, $15 per hour. And actually, I'm going to change that back to X, since I was using X before. So 25X equals 15X plus 50. So basically I'm taking manager B's wage, because they don't earn an extra stipend for anything. They don't have a bonus. They just earn $25 per hour. So I'm setting it equal to manager A's amount. And when we go ahead and do the work, I've got 10X equals 50. Dividing by 10 shows me it's 5 hours. So 5 hours, that's when they will charge the same, or that's when they'll make the same amount of money. So after how many hours does manager B earn more? So it would be after 5 hours, manager B earns more money. And let's take a look at the last one here. You and your friend are saving money to buy a bicycle. It costs $175. And then it says the amount Y in dollars you save after X weeks represents the equation. This equation here, the graph shows your friend. So this is yours, this is your friend. So find out, this is about 15. Let's call this 0, 15 right here is what that is. And let's go ahead and find the slope of that line. So 39 minus 15 over 3 minus 0. So that makes 24 over 3, so that's 8. So your friend earns $8 per hour and starts at 15. So the y-intercept is 15. So their equation is y equals 8x plus 15. And so who has more money to start with? Well, you have more money to start with. So A, you have more money initially, $45 compared to $15. And then who will buy the bike first? Well, we'll go ahead and set it up, and let's see here. This was your friend, actually not you, your friend, we'll say, because your friend was this amount right here, and you are at this one. And so it says you have saved, so this is yours. So we'll go ahead and find out when will they earn the $175. So I'm going to set 175 equal to y, and then solve for the number of weeks it takes to earn that amount of money. So I'll subtract the 45 from both sides. So I get 130 equals 5x. Doing the division, let's see here, 5 goes into 13. We have 2 times with 3 left over, so makes 30, so that'd be 26 weeks. That's what it takes you. And then your friend is going to end up being 175 equals 8x plus 15. So when I subtract the 15 from both sides, we end up with 160 equals 8x. And it looks like we're going to go ahead and do that subtraction. We're going to end our division. We end up with x equals 20. So 20 weeks. So you beat your friend, or your friend beats you. We'll buy the bike first. Your friend will and take 20 weeks, and you take 26 weeks. So those are the problems you're going to see on tonight's homework. Good luck.